Alright, so I think it's working. My thing is flashing. So, again, what we're going to do is we're going to review the point signs and planes material that we talked about yesterday. You guys are going to be providing me the answers. Make sure that you can explain it. Because, again, as a pre-AP math student, the idea is that at some point y'all are going to be taking an AP math course and then for an AP math test. And part of those tests are not just what's the answer, but why is that the answer? You have to be able to give a justification for what your answer is. Okay? So let's look at the first part, A, B, and C. Are they collinear? Nadia, what did you say? Okay, so B and C, you're looking at it like that. You're saying those look like they're on the same line. B and A would be on the same line, and C and A would be on the same line, but together all 3 points are not on the same line. So you're saying no, that they're not collinear, and I agree with that. No, those points are not collinear. All right, moving on to the next one. A, B, C, D, and E, are they coplanar? Okay, so I'm sorry, orange shirt again. What's your name again? Brendan, what did you say for part B? Are those points coplanar, yes or no?
Yes, because they're all on the same plane.
Okay, so you're saying those 5 points are on the same plane. Okay, by a show of hands, who agrees with that? By a show of hands, who disagrees with that? Okay, now, you're getting a whole lot of people disagreeing with you, and that's okay. That's one of the reasons why we talk about this stuff, is if you're not understanding something, let's explain it. So, somebody, who can explain to me, what does coplanar mean? Just in your own words, what does coplanar mean? Emily?
They're all on the same plane. So, like a square with a bunch of dots in it, those are all coplanar.
Yeah, they need to be on the same plane or on the same flat surface together at the same time. Okay? So are these 5 points, particularly point A, is that on the same flat surface with the other ones? In this case, no, they're not coplanar. Somewhere. There we go. They're not on the same flat surface. Now, here's a really good question. This is like one of the best questions on this page. How many planes are there? Okay, I'm going to take a volunteer on this one. How many planes here? Noelle, what'd you get?
3.
3 planes. Who says 3? We got 3 people saying 3. Okay, who said something besides 3? Sam, what'd you say? 6. Who says 6? Okay, we got a few hands going up. Are there any other numbers besides 3 or 6? 1, 5? Okay, now, can you explain where those planes come from? It's not just, so we have answers. Why did you say that? Ensign, why did you said 3, right? Why do you say 3? Okay, so you're looking at just kind of the base of the figure to try and see where the planes are coming from. Yeah, I don't know why it didn't print up that way, but yeah, on your papers, for some reason, those dotted lines, we have a pyramid kind of sitting on in the figure here. Okay, and that might adjust what your answer might be now, right? Okay, and I'm sorry, what's your name again? Lauren, what did you say? Okay, so, and how many was that again? 5. Okay. The biggest issue with these is not so much about whether it's the most common answers are going to be 5 planes or 6 planes. And the question is, here, this overall kind of parallelogram that we see here and this kind of square-ish looking base here, are those the same plane or are they different from each other? They're the same plane. And that's what a lot of students will think of as being 2 different planes. So look at like this base of the pyramid and this overall parallelogram looking shape is 2 separate planes. But if they're on the same flat surface at the same time, it's the same plane. So in this case there's 5. What is the intersection of line AE and line AB? Let's see. Sam again. Point A. And you can just kind of look at those 2 lines and see that they're going to touch each other right there. how could I tell that point A is the point of intersection without having to look at the figure? Okay, Sam, you're retired for now. Just put your hand down. I appreciate the enthusiasm, but I want more people involved. Casey, what'd you say? Exactly, because both lines include point A in their name, that indicates that they have to intersect each other at that point. So point A is the point of intersection. So this line, AE, and the plane F, where do those intersect at each other? What's your name again, sir? Connor, what'd you say? Point E. How many say point E? See a whole lot of hands, so we're either all right or all wrong. I agree with point E. And last one, the intersection of the two planes. First of all, two planes. When two planes intersect, what must be formed? A line. Okay, so what line is formed when those two planes intersect? What's your name again, sir? Jesse. So you guys watching, it's beginning of the year. I'm still learning everybody's names. Jesse, what'd you say? Line ED. By show of hands, who says line ED? Whole lot of hands are going up in the air. I agree. Line ED. So overall, how are we feeling with this material so far? Okay. Can you identify the points? Can you identify planes? Can you see how they're intersecting, etc.? Now, moving on. B, C, F, and G, are they coplanar? Now, here it doesn't say explain. It doesn't ask you to give me a reason why. However, you still need to be able to think it out. If I ask you, why did you answer that, you still need to be able to provide me a reason why. So, practice problem 1 here. Are those 4 points coplanar? Volunteers. Let's see. I want somebody over here. Emily, right? I know it's Barry. What's your first? Noel? Something? What? Elizabeth. I'll get it eventually. I know it's Barry for some reason. But, Elizabeth, what'd you say? Are they coplanar? Yes or no? Yes? How many of you said yes? See a whole lot of hands up in the air again. I agree with that. They can sit on the same flat surface at the same time. So good. List 4 other points that lie in, other coplanar points that lie in a different plane. I'm going to just go ahead and give my answer on this one because there's a lot of answers that you could have given. There's not just one right answer. In this case, I'm saying C, D, H, and G. Those are the 4 points that I'm selecting here. D, E, H, and G, are they coplanar? Anybody here? Anybody? Gwen, what'd you say? No, G is not coplanar with the other points. It's not going to sit on the same flat surface. I agree with that. All right. List 4 other non-coplanar points. Again, I'm going to just kind of give you my answer because there's lots of answers that we could have had here somewhere. Where is my answer? Maybe I didn't put one. I don't know. List 4 other non-coplanar points. We could say like E, G, C, and D. Those would be 4 non-coplanar points. Okay? Does anybody have any questions right now as far as determining when something is coplanar or non-coplanar? All right. Moving on. Here, name the plane that contains Q, R, S, and T in 2 different ways. Again, there's lots of ways that you could have named it. There's no 2 answers that are correct or not. So I'm going to just give you 2 examples, QRS and RST. Those are 2 examples of ways that we could have named that plane. Now, this is where I'm going to go back to you guys. NP, Q, and S. NP, Q, and S. Are those coplanar to each other? Yes or no? Well, I'm hearing a lot of mumbling, like I'm not sure about what the answer is. A lot of people are saying no. Can anybody give me a justification for why we're saying no? What?
I put yes.
You put, so you have a disagreeing answer. You said yes. Okay, well, let's see. iPad stopped following me. There it goes. All right, so I got at least one person saying yes, but a lot of people said no. So who said no? Alex, why did you say no?
Because N and P are a different plane from Q and S.
So you're saying N and P are on a different plane from Q and S. And what was it again? Connor, what did you say yes for?
So it's at an angle, but they're still on their own plane.
Okay, so even though it's not a face of the prism, I can still make a flat surface with those 4 points. Okay? So let's see. Does that change anybody's answer from no to a yes? Got one person convinced. Well, guess what? Somewhere. Yes. Those points are coplanar. And the explanation that Connor gave as far as that, even though it's not a face of the prism that was drawn, do those 4 points, can they reside on the same flat surface together at the same time? Absolutely. And here's, if you take your pencil and you kind of, so we have N, P, Q, and S. We have those. So here, if I connect all 4 dots together, do I have a flat surface there between the 4 points? I do. It does not have to be one of the faces that was drawn on the prism. Question? Yes. So yes, those are coplanar. All right. Points M and R. Let me clean this up here. M and R, are they collinear? Let's see. I keep saying, I again appreciate the enthusiasm. Jordan, what did you say? Yes. Why did you say yes? There you go. Any 2 points in space, any 2 points always contain or always may contain a unique line that connects them. So even though M and R, here's M, here's R, there's not a line drawn between those 2 points in the figure as far as the prism is concerned. But are they collinear? Absolutely. That's one of Euclid's 5 basic postulates that says between any 2 points there is a unique line segment that will connect them. So that is true. That is yes. P, N, and Q, are they collinear? Yeah. N, P, and Q, if we're looking at those, let's pick another color here. So we have N, we have P, and we have Q. Are those collinear? No, there's not a single straight line that connects them. What would we describe them as if not collinear? They're non-collinear, but what's another way that we could describe them? Say that again, Sam. They are coplanar. What did I tell you yesterday as far as what makes a plane? Any 3 non-collinear points make a plane. So they're not collinear, but they are coplanar. Okay? Does anybody have any questions? All right. So let's go through these a little bit quickly. Number 9, LM and NM, those 2 lines. Alabama, what did you say?
I said no, because L is on the plane.
Yeah, those 2 lines are not on the same plane. Is that what you're saying? I'm sorry, is that what you're saying? Okay. Who says no? Maybe half of the class is agreeing with you. Does anybody say yes? I can assume that the hands that didn't go up with no must by default say yes. Okay? So, are those 2 lines coplanar? You bet they are. What did I just say? Any 3 non-collinear points always make a plane. Always. Whether it's drawn for you or not. Just like what we saw in the last diagram with the rectangular prism, we had that kind of diagonal shaped plane where it wasn't drawn as a face of the prism, but could we make a flat surface between them? Yes, we could. Therefore, we classified it as coplanar. If I have any 3 points that are not on the same line, whether it was drawn that way or not, there will be a plane that contains them. Points Q and R, are they collinear? Yes or no, guys? Yeah, just like what we answered on the last one, those are collinear because any 2 points in space will contain a unique line that contains them. Points L, N, and R, are they collinear? What's your name again right here? Haley, what did you say, yes or no? Why did you say no? You said no because they're not on the same line. Well, L is right here, N is right here, and R is right here. They're not on the same straight line. They're not collinear, but they would be coplanar. Line LM and Q. plane Q, are those points, or is this line and that plane, are they coplanar? Yes or no? What'd you say? Why'd you say yes? Because they're on the same what? Because they're on the same line? That's why they're coplanar? Darius, what did you say? So you're saying that they are coplanar because they would make a flat surface between them. Okay? So we have that line and that point. So LM and Q, are those three non-collinear points? So any three non-collinear points will create a plane. So yes, they are coplanar. So NM and point R, same thing. Those are three non-collinear points. So they will create a plane. NQ and NM, are they coplanar? Sure. Both of them contain point N, so they intersect each other. So I have N, Q, and M as three non-collinear points. Therefore, they create a plane. Here, the intersection of NM and LM, because point M is in both of the lines, they have to intersect at point M. What is the intersection of line NM and QN? Again, because both lines contain point N, they have to intersect at point N. So here we have plane K and line LM. A plane and a line, what do they make when they intersect each other, class? I'm not very convinced. I heard like two kids say it. A line and a plane, when they intersect, what do they make? A point. All right. So what point does this plane and this line intersect each other at? Who can tell me? Point M. Good. And the intersection of plane K and another plane. So again, one more time. I want a whole class answer. Two planes, when two planes intersect each other, what is created? A line. So what line is going to connect these two planes together? Who can tell me? Keep seeing the same hands. Let's see. Max Shirt. Again, what's your name again? Nathan, what'd you say? Line what? Line L. Okay, so I just want to make sure that this is your answer. L, M, R. Is that your answer?
No.
Why isn't that your answer?
Because I changed my mind.
Okay. Why did you change your mind?
Because everyone was making fun of me. That's not the right answer.
What did I tell you yesterday about naming lines? How many points name a line?
Oh, two.
Two. If you give me 3 points to name a line, it's wrong no matter what.
It says MN.
Okay, so you're saying line what?
MN.
MN. Okay. I don't remember because I haven't looked at it in a while. Do we say line MN?
Yes.
Okay. Is that what I said? Yeah, NM. Yeah, any two. Oh, use 2 points to name a line, never 3. Okay, so here's the last part about parallel, perpendicular, parallel, intersecting, or skew. DH and BF. Let's see, red shirt in the back behind Sam. What's your name again, please? I'm sorry? Priscilla, what did you say for number 19? Parallel. Who says parallel? Remember, if they're parallel, they have to make a plane. They have to be on the same flat surface. Okay, so there's parallel. Number 20, let's see, in the back. What's your name again? Cortland, what did you say for number 20, sir? Speak up just a little bit, please. They're intersecting. Who says intersecting? All right, so either all are right or we're all wrong. In that case, point D and D is shared, or point D is shared between them, so they're definitely intersecting. EG and AC, what are those going to be? Who can tell me? Parallel. I agree with that. Again, they make a flat surface between them. EG and BD, process of elimination. Connor, what's that going to be? Those are skew lines. That's an example of two lines that will not intersect, but they will also be non-coplanar to each other. That's the difference between parallel and skew. So here, I'm going to just go through these these last four here real quick. Are these planes parallel to each other? No, they're not. Those planes are going to intersect and touch and create a line. These planes will be parallel to each other. I want you guys to understand, lines can be parallel or skewed depending on whether they're coplanar or non-coplanar. There's no such thing as a skew plane. Planes either intersect or they're parallel. There's no skew planes. So here the planes will not intersect. Here the planes do intersect. Okay? Now, again, this whole exercise was primarily about making sure that you can identify the planes when you see them, determine what kind of lines you have, parallel, perpendicular, skew, etc., things like that. Before we wrap this lesson up, does anybody have any questions? Okay? The whole idea of like those three non-collinear points making a plane, that one always catches kids off guard because like go think back to that prism where we had those diagonal lines to get to, and we were seeing are they parallel to each other, or are they coplanar to each other? I should say. Well, it doesn't have to be drawn for you in a figure. Those kinds of questions are making sure do you really understand, what these undefined terms make and how they interact with each other. And just real quick before we close it out, how many undefined terms are there in geometry? Three. What are they? Real loud, everybody. Point, lines, and planes. Those are the only three undefined terms that we have. Everything else in geometry is going to be a defined term. Okay, so we're going to go ahead and wrap it up here.